Here we have a function defined from -1 and 1 to b. Now the function is f of x equals tan inverse of 2x by 1 minus x square. Then if this function, if this is the domain -1 to 1, open brackets is the domain and b is the range, and if this function has to be 1 1 and on 2, then what exactly is b? First let us understand this one, 2x by 1 minus x square in this domain -1 to 1. Okay, so obviously, if you can see this function f of x, f of minus x is equal to minus of f of x. Right, this is clearly right one, because if you replace x with minus x, we will get minus 2x by 1 minus x square, which is uh, f of minus x is equal to minus of f of x. That is an odd function. What does that mean? Whatever is in quadrant 1, so this the graph of this function is symmetric about the origin. Okay, right. So let us understand this function when x is greater than 0. Then we can use the symmetry to understand how is it when x is lesser than 0. Right. This graph is, we are just concerned about 2x by 1 minus x square. This graph is symmetric about the origin because it's an odd function, 2x by 1 minus x square. Now, when x is greater than or equal to 0, how does it behave? Okay, x greater than or equal to 0, that means 0 to 1. We are concerned about till 1 only, right? If 0 to 1 we have figured out, 0 to minus 1 is symmetric with respect to same symmetric, right? Just the negative values. So when 0 to 1, the numerator is increasing, right? 2x, when x goes from 0 to 0.1, 0.2, 0.5, 0.9, etc., numerator is increasing. But 1 minus x square, right? X square is always lesser than 1. 0.2 square, 0.5 square, 0.7 square, whatsoever. It is always lesser than 1. So as x is increasing, 1 minus x square is decreasing, right? For example, 1 minus 0 is the highest versus 1 minus zero point 0.9 square or 0.99 square. Likewise, the numerator is increasing, the denominator is decreasing, and this denominator will approach 0. Right, as x approaches 1, this denominator approaches 0. Sorry, x square, 1 minus x square will also approach 1. So 1 minus x square will approach 0. What does that mean? 2x by 1 minus x square will approach infinity. At the same time, the numerator of this fraction is always increasing, denominator is always decreasing. That means this fraction 2x by 1 minus x square is continuously increasing. Okay, if you look at the graph, it will look something like this. At 0, we are talking about 2x by 1 minus x square. At 0, it will be 0 because x is 0. As x increases towards 1, right? So the numerator is always increasing, denominator is always decreasing, right? And as it comes closer to 1, denominator becomes almost 0. So it goes up to infinity. Now, this is the fraction, this is the function when 0 less than 0 less than or equal to x less than 1. Okay. Now, we have already realized f of minus x is equal to minus of f of x. Right, because x only, this x will be replaced with minus x whole square is still x square. So this is an odd function. What does that mean? This function is symmetric with respect to origin. That means whatever is this, right? If we whatever is this one, same will be there symmetrically with respect to origin. What does that mean? If x, y are there, minus x, minus y are also here. Okay. X, y are there, minus x, minus y will be here. For example, so what also that means is, if you rotate this graph by 180 degrees, you'll still get the same graph. Okay, so for example, this point, minus x, minus y, somewhere around minus zero point 0.6 and minus zero point 0.5. Here we'll see plus zero point 0.6 and 1.5, minus 1, minus zero point 0.6 and minus 1.5, plus zero point 0.6 and plus 1.5 roughly. Right. So if you see xy, you will have minus xy, minus x, minus y also on this graph. So when we realize the graph, when x is greater than or equal to 0 and 1 lesser than 1 is like this, obviously that also means the graph in the quadrant 3 is like this. It is just a reflection of quadrant 1's graph. Okay, so now what does that mean? This function 2x by 1 minus x square can take any value from minus infinity to infinity when x lies between minus 1 to 1. Right, that's what we have realized. So it can take any value between minus infinity to plus infinity. And at the same time, this this is continuously increasing. Right, this is continuously increasing. That's why this is a 1 function also. 1 function, this is continuously increasing. We have just realized because the numerator is increasing, the denominator is always decreasing. So it is continuously increasing when beyond 0 when it is here. And this side it is just a reflection. So minus 1 to 1, the graph is actually continuously increasing all the time. Okay. So now what we are concerned about? We are concerned about tan inverse of this one. Okay. So this function is trending between minus infinity to infinity, right? And it has got all the values, whichever value you want. You want minus 100, there will be some x. You want plus 200, there will be some x. You have all the values, and all the values because these are continuously increasing, this is actually 1. So tan inverse of minus infinity to infinity, it will run between minus pi by 2 to pi by 2 open brackets. Right, minus pi by 2 to pi by 2. When it is that, then tan inverse of this thing, tan we know is 1. Right. So tan inverse, this also, because this function is also continuously increasing between minus infinity to infinity, this also is actually 1. Okay. When this is mapped with pi by 2 to pi by 2, this will be 1. If we have, if you are mapping minus pi by 2 to pi, not just pi by 2, if you are increasing this, then we cannot say this. But if it is between minus pi by 2 to pi by 2, then it is, then it will be 1 and onto. Onto means whatever value, whatever value, whatever value, minus pi by 2 to pi by 2. Any value in between. So for example, 0, or 30 degrees or pi by 6, pi by 3, whatever. All the values, they will appear, right? They will appear at some point. And this, because this 2x by 1 minus x square, it is taking all the values from minus infinity to infinity. So tan inverse of this will take all the values from minus pi by 2 to pi by 2, except excluding minus pi by 2 and pi by 2. It will take all the values. So if you want pi by 4, if you want pi by 4, you will find some x that will map, that will give 2x by 1 minus x square is equal to 1. That means tan inverse of 1 is actually equal to pi by 4. Right. So whatever value you want between minus pi by 2 and pi by 2 will have some x that will give tan inverse of this expression will give that that value of that value, right, between minus pi by 2 to pi by 2. So that means this function is onto also. When the range is minus pi by 2 pi by 2, minus pi by 2 to pi by 2, which is open brackets because tan is not defined when it is closed brackets, right? Then this function is both 1 and onto, right guys?